Oh, so you still have sent me another question in which you have to prove something, and the question goes something like this. So let us try to solve this one now. It is given that the voltage across the source is V1, and we have a controlled current source over here with the value alpha times I1, where I1 is the current which goes across this R1 resistance. And we have to prove that V2 is equals to V1 times something. Okay. So we will apply our favorite mesh analysis in this equation also. Let me consider this is equals to Im1, the mesh current, and the mesh current over here, let me say that is equals to Im2. Because a source which is like a current source is given, so for mesh 2, it becomes a super mesh. And you know that for super mesh, you just have to write like Im2 will become equals to minus of alpha times Im1 or I1. As you can see that this I1 and Im1 are following each other. So using mesh transformation, I can say that I1 is equals to Im1. Now I am left to write the mesh equation for this particular mesh, and that is the sum of resistances in mesh 1 multiplied by mesh current 1 minus the common resistance in 1 and 2, which is R2, multiplied by mesh 2, or the current of mesh 2. And this should be equals to my source voltage, although it is given to be 2 volts. But in question, as it is given that we have to prove in general for V1t, so I would consider this is equals to V1. Okay. Now in this equation, I can apply that Im2 is equals to minus of alpha times Im1. So I can expand this equation to be R1 times Im1 plus R2 times Im1 minus R2 times minus alpha times Im1 equals to V1. So if I will collect it further, I will get it like R1 plus 1 plus alpha times R2. You see that this will become minus minus plus alpha R2 and R2. So R2 and alpha R2, I have taken it like this, multiplied by Im1 should be equals to V1. Okay, this is what it is going to be like. Now, since we have to find out what is V2 or what is going to be V2, remember that V2 in this circuit is going to be the voltage across R2 resistance. And I can write that the voltage across R2 resistance can be written as Im1 minus Im2. So because the current flows like this, it's a passive element. It is Im1 minus Im2 times R2. Fine. Im1 minus Im2 times R2. So you can write this one as Im1 minus of minus alpha Im2 whole multiplied with R2. And from here you can write that V2 is nothing but Im1 plus alpha times Im1 times R2, because Im2 I wrote as minus of alpha and it was a minus sign. So now I can write that V2 now can be written as V2 can be written as 1 plus alpha times Im1 into R2. Fine. And the value of Im1 we can put from this equation, because we know that since Im1 is equals to V1 upon R1 plus 1 plus alpha times R2. And if I will put this value in the equation above, I can write that V2 is equals to 1 plus alpha R2, and Im1 can be replaced with V1 upon 1 plus, sorry, R1 plus 1 plus alpha times R2. So it is almost solved now. So now I can write that V2 is equals to 1 plus alpha times R2 V1. And if I can take 1 plus alpha R2 common from this, so I can write 1 plus alpha times R2, I'm going to take common. Then this is going to be 1 plus R1 upon R2 into 1 plus alpha. Okay. And you see that this can be cancelled with this particular thing. And finally, I will get the equation that V2 should be equals to V1 upon 1 plus R1 upon R2 and multiplied with 1 upon 1 plus alpha. So this is the relation which we were asked to prove for the given circuit. You see that this is the equation which we were supposed to prove. Now they are asking us, how do you explain the results if you obtain alpha equals to -1? So if alpha becomes -1, then what will happen? If I will have alpha equals to -1, and there will be a only small change that in this circuit, if alpha becomes -1, then Im2 or the mesh current which is flowing in mesh 2 will becomes equals to minus of -1 times Im1, and I will get Im2 equals to Im1. So if I will have alpha equals to -1, I will have alpha equals to -1. I can simply say that this direction will change like this. Okay, because it is given that if it is alpha times I1, the direction is this, and if alpha becomes -1, so I will be having the current flowing in this particular direction. And you would see that the voltage across this resistance, which was Im1 minus Im2 into R2, will become 0. So we will find that it will as if this point has become short circuited. Okay, as of this point has become short circuited, because V2 will then become equals to 0 if I have alpha equals to -1. This is a possible explanation of what they're asking us to solve for. That's it for the given question. Thank you so much.